Welcome back to our channel, The Catalyst, the home of solutions. So today we are going to answer June 2021 Advanced Level Computer Science Paper 3. Now, in this paper we have section A, which is programming, and section B, which is database. So we'll start with section A. Binomial expansions are sometimes aided by a tool known as a Pascal triangle. Pascal triangle is an array of numbers which is triangular in nature. An example is given in the figure 1 below. So we have this figure for the Pascal triangle. Here we realize that it is an n-to-n matrix where n is a natural number. The leading diagonal of the matrix and the first column are made up of ones only. That is, if the matrix is A, then all A of I1 are ones and all A of I are ones for each line row I of the Pascal triangle. Elements of each line run from A of I1 to I of I, but A of I1 and I of I are ones and can be filled in advance. To fill each cell, that is A of ij, within the rest of the triangle, we go from A of I2 to A of I minus 1, with j ranging from 2 to I minus 1. So every A of ij is equals to A of I minus 1 j plus A of I minus 1 j minus 1. So that's 1. Do the following in your answer booklet. With the above in mind, copy the Pascal triangle in figure 1 in your answer booklet. Attach it to the next two lines of the Pascal triangle. Now, so first of all, I will use Notepad for that, just to show us how it's supposed to look like. Okay, so if we consider what we are seeing here, this Pascal triangle, they said we should add two lines. So I will create a new tab. So it starts with 1, and then below we have 1 space 1, and now we still have 1, and then we have 2 and 1. Then now we have 1, we have 3, we have 3, and we have 1. And then the next line we have 1, we have 4, we have 6, we have 4, and we have 1. Okay, so the next line will be 1. So what happens is that to write this, what you do is you first of all write the 1, and then you sum up these two, as you can see here. Wait, let me first of all look at the last one. Okay, that's exactly what they had as last. So the next number, we'll write our 1. We'll add these two numbers for it to be 5, and then we add these two also. So the next number after 5 will be 10. Then the next we add these two, which will still be 10. And then lastly, of course, we have 1. We go to the new line. We start with 1. We'll add these two. So you add these two, we'll have 6. If we add the next two, these two, we'll have 15. If we add the next two, these two, like this, we'll have 20. And then lastly, we'll add, oh, looks like there was a problem. I did not add these two. There was supposed to be 5 here before 1. Yes. So that now down here, add these two, we have 6. Add 15, we add 20. We add these two, we have 15 again. And then we add these two, we have 6. Oh, sorry. We add these two, we have 6. And then we have our 1. So that's how the Pascal triangle is going. It's supposed to look like. This is a Pascal triangle, and these are the two rows we have added. So we've answered that first part already. So we'll move to question 2. Write an algorithm to fill the leading diagonal. Now the leading diagonal is these ones. We see these ones here like this. Okay, that's the leading diagonal. These ones we see here. I don't know if I have to circle it for us to see what I'm saying. But these are the two. Okay, so how do we do that? The leading diagonal is A of I, okay, or A of ij when I is equals to j. Okay, so to write the pseudocode, for the pseudocode, well, I will use a algorithm for us to write the algorithm. Okay, I'll use the program algorithm. So let's see how that can be done for the leading diagonal. So for the leading diagonal, of course, we'll declare I and j. So to fill the diagonal, it's going to be I must be equal to j. So if we are considering just I, okay, if we are considering just I, we'll say that we use a for loop, and our for loop will be, the variable will be I. It has to start from, since we skip the first row, to fill the rest, it will start from 1 and end at a row. at n minus 1, since n is the size of the array. So if we have this inside now, what we do is we assign. We are going to say that a of I should be equals to 1. As simple as that. Okay, but now this is a two-dimensional array, and algorithm does not accept two-dimensional arrays. It does not accept two-dimensional arrays. So in a nutshell, what we are supposed to have is this: we'll have a for loop that starts with I, that is I from you can say I starts from 1 to n minus 1. Okay, and then inside what we do is we'll say I of a of I equals to 1, should receive 1, and then we use the next counter. We can do it like this, or we may also decide that it can be done in this other way. We can also decide to use two loops. We can still decide to use the I loop and the J loop. Okay, so for J, where you want to use J as another loop, okay, the counter will start from 1. Okay, it's still going to be the same thing. So inside now, we'll say that we'll put the condition if I is equals to J, then A of I of J should receive 1. So any of these ones are correct. Okay, so move to the next question. Our next question says, write another algorithm in your answer booklet to fill the first column of your Pascal triangle. It then fills the remaining columns of the matrix A with zeros. Okay, so to fill the first column, we will have this. To fill the first column, we'll just copy this. It's going to look like this. So our counter will start from 0, okay, to this. But now it is the column. The column is fixed, and it is column at position 0 that will receive 1. As simple as that. That is to fill. This one will be to fill the first column. Okay, that will be to fill the first column. Now to fill the rest with zeros. We'll just start from 0. Okay, we'll start from 0. We'll fill the rest with 0. To do that, we need these two loops. Okay, we need the two loops. As simple as that. But now we'll start from 0. Okay, and end at n minus 1. Then we change this. We'll say it will receive 0. That's all. To fill the rest with zeros. So c'est bon. So we move Z. Write yet another algorithm to fill the rest of the row apart from the first and the last element of the Pascal triangle. Entries beyond the diagonal elements are filled with zeros. Okay. Z. But I think. Okay. Apart from the first and last, entries beyond the diagonals are filled with zeros. Okay, this D is we are supposed to instead fill the non-zeros. Okay, to fill values for the non-zeros. Well, for the non-zeros, what are we going to do? Because zeros are above, so this one is for the non-zeros. That's those cells. The non-zeros, of course, we'll still use this. We'll start our I from 0. Then we are going to have another loop. Maybe we'll call it still J, but J will start from 1. and end at I minus 1. Okay, I minus 1. So, and now to fill it, just like we use, remember they gave us the formula. This is the formula here, and they said that it is supposed to start ranging from 2 to I minus 1 for J. He said J is ranging from 2 to that. So I in the context of arrays in C, for instance, the index starts from 0. So if we move to 2, it means we are moving from 1 to I minus 1. Okay, so now J of A of I of J will be equals to, so let's just look at this formula that they propose here. They said it should be equals to A of I minus 1 of J. So that's it, A of I minus 1 and then J plus, should still be A of what, plus A of I minus 1, J minus 1. So I minus 1, J minus 1. As simple as that. So that is it. That is it. It's a bomb. So let's move to the next question. We are done with task 1. In task 2 now, transform the algorithm in task 1 into programming language functions or procedures. Okay. Write a programming language function or procedure that prints all the elements of n times n. Okay. So anyway, we'll convert all these our procedures we wrote before. These ones here. We'll convert all of them. Okay. We'll convert all of them. This one was to fill the first column. So, okay. So let's convert it to C. So let's go. So start with including the standard input output library. Then I will start with the procedure. I'm sorry, it's not an algorithm. So procedure to fill first column. So we surely take in a matrix A of size. Okay. To fill the first column. So for the first column, if I take an I will say for I starting from 0 for the first column, I less than n. We also take in a parameter n for the size of the array. So then we have I plus plus, and inside now we will simply say that A of I should receive 1. So that is the first procedure. So the second procedure was to, this one is instead diagonal. This first row is supposed to be 0. For the first row, this is what it's supposed to do. That it receives 1, sorry. This is for the first column. Okay, now let me write the code for the diagonal. To fill the diagonal. To fill the diagonal, I of I should receive 1. Okay. So that is it. The next is to fill the rest with zeros. Fill the rest of the columns with zeros. So since I copied it, most of the things fill zeros. Okay. Now to fill the zeros, we need 2 loops. We need this loop and we need another loop, which will be J instead. So we have I and J in this one. This one now is J. This is J. So that's it. Now the last one now is to fill the rest of is to fill the rest of the cells. That's the addition, adding up those numbers. So we may say fill others. Okay, so to fill others, we said it starts from 0 here. Here it ends at I minus 1. Okay, and we are to say that A of I minus 1 J plus, copy this, equals to J minus 1. So that's it to fill the rest. And now let's move to the next one. Created for, it said write question B, write a PL function or procedure that prints all the elements of the n by n matrix. Okay, so maybe we'll call it, let me take this. Maybe we'll call it display matrix. Okay, now to display the matrix has to print the element. We'll use printf, and we'll start this and end at n minus 1. Okay, so we'll have this, and inside now we'll print the elements using percentage %d, and the percentage %d, something like this. I think, or maybe we'll use tab, where this will be A of I or G. Okay, so that's it. Move to question C. Question C, write the main that calls the procedures from A and B above in the right order so as to populate and print the elements. Make sure your program works. Okay, so we'll now write our main function. In the main function, we'll start by we'll first of all declare our matrices, which can still be declared as a global variable. Anyway, we'll start with n. Okay, and also the matrix, which I'll call m, of size. We don't know the size, so we cannot even declare it now. So now n will do a printf, sending a message, enter the size of the triangle, enter the height of the triangle. So, and then we'll scan f, which is percentage %d. Okay, we'll put n. Okay, so with this now, we can now declare our matrix m, which is of size n by n. So the first thing we'll do is we'll fill zeros. Fill the zeros. That's the first thing we got to do. So we'll call on that procedure that helps us to fill zeros. This one. We'll call on the first thing is we need to fill those zeros. And fill zero will take as parameter, it will take m and n. So maybe I will just copy this and I'll modify it. So after filling the zeros, what are we going to do? We'll fill the diagonal. Or maybe the first column. Fill first column. So to fill the first column, what was the procedure again? This is it, first column. So I'll change it. Fill first column. Now, after filling the first column, we'll fill the diagonal. Okay, fill diagonal. I think so. Fill diagonal. And to fill the diagonal, this is the procedure. So filling the diagonal now. After that, we can now fill the others. Okay. few others. Few others will use this. Which will take M and N. And then lastly, display the triangle. So to display the triangle, we use this. Okay, so we have M and N. Think that is it. So maybe we'll call it triangle or Pascal, or let's say yes, let's just call it Pascal. Pascal triangle. Let's see. So let's see if you okay. You see the array type has it looks like we'll have to we'll declare N as a global variable. So I will just say N should be a global variable so that this my issue of array type, maybe I will just put N inside it. So I don't need to take this as a parameter if it is a global one. So I don't need all of this. As a global variable, not even like this. It's going to be hash defined. Anyway, let's put it the way it was. It's okay. Everything when you call is supposed to run without any issue. So enter the height. Let's say 5. Oh, 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 that display looks like there is a problem. Uh, there's a problem with displaying the values. After each line for display, I was supposed to get a new line. After each one, let's see if there's still gonna be any error. Still not doing what we want. Hey, what could be the problem? Oh, see, this is where the problem lies. We're supposed to start from 1. Think this should be okay. Why is it not going to me? Why is it not displaying me? This is strange. This is really strange. Why is it not displaying on the image? Oh, is it that almost with this? Like this? I got. Why is it displaying all on one line? This is, I see. Oh my god, my bad, my bad. It's supposed to be here. Oh god. No wonder. Oh, I think this is okay. Everything is okay now. Yeah. Voila. So that's it. That's a Pascal triangle. Oh, I was wondering. So everything being equal, everything is moving smoothly. And I think we are done with the exercise. We are done with the exercise. So we'll move to the next. Okay. In our next video, we'll move to section B. So thank you very much for your time. See you in our next video. God bless you.